Hey there, Year 8s, Mr. Herman here, and this is the essential assessment lesson, Determine Sample Space in Chance Experiments. The learning goals for this lesson is to look into what a sample space actually is, and the success criteria for this lesson is to be able to construct sample spaces for single-step experiments with equally likely outcomes. I've gone ahead and grabbed a few examples here from Essential Assessment for this skill. A sample space effectively just talks about the different possibilities from a certain event happening. Now this event can have either equally spaced chances, like a 1 in 5th chance for the spinner, or it could be you can have a higher likely or lesser likely chance for a certain event happening, depending on what scenario you've been given. In this case, we've got a spinner here, and we're going to list a sample space for the spinner from smallest to largest. So we have 1, 2, 3, 4, 5. That is all there is for the sample space. So really simply, this is 1, 2, 3, 4, 5. Now a lot of the questions from question 1 up to question 5 follow this format. You've just got to write down what the different numbers provided to you are. Question 6 onwards have questions in the format of this. Which list of outcomes will give you a 1 in 2 or a number in another number theoretical probability of landing on the number 2? So there's a 1 in 2, theoretically, 1 in 2 probability of landing on the number 2. So let's just assume here that these are a dice and they've got the numbers listed within this dice. So if you were to think of it as a 6-sided dice like this, some of them are 6-sided, others are 5-sided. And you're looking for a specific die. So this has a 2, and then another 2, and then a 4, and the other sides have 5, 5, 5. Quite a weird dice. You can either have 5 or 6-sided. And we're looking for, from the list provided here, which of these will give a 1 in 2 probability of landing on the number 2. So a half chance. So remember, 1 in 2, or 50%. So we're expecting half of the results of what's been given here to be the number 2. So of the 6, we're expecting 3 of them, and of the 5, we're expecting 2.5. But it's an odd number, it's a bit tricky. So we can definitely rule this one out. So 1 in 2 chance, I'm looking for half of them. This is the one here, because half of these numbers provided out of the 6, 3 of them will give you the number 2, and this will give me a half chance of rolling the number 2. In other words, there's a 50% chance that if I were to roll this, that I'll get a number 2, considering that half of them are 2. Another way that we can tackle this is if I'm looking for the number 2 and we're dealing for half of them, every time I cross a 2, I should cross a non-2 number. So every time I cross a 2, I should cross a non-2 number. Every time I cross a 2, I should cross a non-2 number. If we can do this and cross every single 2 out, and every single number out, then we know we found it. It doesn't work with other ones. So if I have a 2, cross a number out. If I have a 2, cross a number out, we've got these 2 numbers left. So it can't be this one. 2, cross a number out. 2, cross a number out. We can't cross 2 and another number out. So again, it can't be this one. So this is the only scenario where this works. We're going to use the same logic. Which of these outcomes will give you a 1 in 3 theoretical probability of landing on the number 2? So 1/3, or 33.33%, 1/3 of them have to be the number 2. So let's look at this one. I have a 2, cross this one out. I have a 2, I'm going to cross this one out. Hold on, I've got to double check what the actual question is asking for. This says 1 in 3. I just followed this 1 in 2 format. So this is a 1 in 3 theoretical probability. So every 2, I cross out, I've got to cross another 2 non-2 numbers in order for this to work. So every 2 non-2 numbers. This is the only one that can work. It's the first one, luckily, one of them. And this makes sense. 1/3 of them, so out of the 2 numbers that are number 2, 2 out of 6, it's the same as 1/3. There's a 1 in 3rd chance of getting the number 2. This has to be it. Let's try with this one. Can't be this one, there are no number 2s. Try with this one. For every 2 I cross out, I'm going to cross 1, 2 numbers. Every 2 I cross out, I'm going to cross 1. We can't do this one. And every 2, 1, 2. Every 2, 1, 2. We've got this 2 left. as you can tell, I'm recording this at school because I'm at school today. So this one can't be the one. So this is the only answer that we have left. There are different processes or different methods or approaches that you can do in order to get your solution. Whichever works best for you, you can apply that. Got two more examples here. This one is question 11. We're selecting a yellow counter at random. Selecting a yellow counter at random is 2 times more likely than which color. And I should point out that there should be a word here, which other color, just so it's not confusing. Okay, so let's break this question down. Selecting a yellow counter at random is 2 times more likely than which other color. So let's see how many yellow counters we have first off. So yellow, we've got 1, 2, 3, 4. So yellow, we've got 4 of them. Now selecting a yellow counter, so selecting out of the 4 yellow counters, is 2 times more likely than one other color. So this is twice as likely to happen from another color. Twice as likely to happen. So if a certain number, which we don't know, we'll call x, if we have twice as many amount of that, we end up getting 4. So obviously we have to start off with a number that is less than 4. This number, the only number that can work is 2, because 2 times more likely than 2 will give me 4. So we're looking for a counter that only has 2 of them in there. Can't be red because it has 3. It can't be blue nor purple because that's 1 each. So it must be green. So selecting a counter, selecting a green counter. So you'll just have to type in green, because green is the only way this can work. Now you will have scenarios where you will be given a set of counters and you're going to see which one is 2 times more likely or 2 times less. If it is 2 times less likely, then you will have to find a number that's higher. So if this said 2 times less likely, the amount of counters that we have to find have to add up to 8, and so we have to look for the color of 8 counters. If this was a 2 less than yellow, but this is 2 more, so in this case it is green. Last question here. This one, it's got a lot going on, this question 16 onwards. So if you do struggle with the questions from 16 onwards, that's okay. These are quite advanced questions. Which spinner is 2 times more likely to land on pink than green? So 2 times more likely to land on pink than green, and equally as likely to land on orange than pink. Equally as likely. So there's 2 things going on. Let's look at this first one. 2 times more likely to land on pink than green. So for every 1 green, I'm expecting 2 pink. This follows this format. So if I have, it's double the amount. If I had 8 green, hypothetically, on a spinner, obviously there's not 8, but there's different amounts here that are less than 8. But if I were to have 8 green, I'm expecting 16 pink, because it's 2 times more likely. 2 times more likely. So we're looking for this scenario where there's double the amount of green that there is pink, and also whatever amount we get for the pink has to be the same or equally as likely to land on orange. It has to be the same as orange as well. And so the only scenario that can work is this one here. Because here, for every 1 green we have 2 pinks, and because we have 2 pinks, this is equally as likely to land on orange as well, because there are 2 oranges too. Doesn't necessarily matter about this blue. It has no effect to what the scenario has been provided or given. All of these other ones don't work. This one here, pink, is 3 times more likely to land on pink than it is green, because there's 3 pinks to 1 green. This one here, we have no oranges involved, there's only yellow, so it can't be that one. And this one here has no oranges as well, it can't be this one. So out of those 2, it must be this one. Alright guys, that is the skill for Essential Assessment. I will be seeing you guys tomorrow, Tuesday, and on Wednesday I won't be seeing you because I will be having my second jab. So I will be seeing you Tuesday. We'll play a few maths games and we'll stray away from Essential Assessment, ease back into maths for this crazy year that has been. For now, work on the skill, and I'll see you guys tomorrow. Tell you all.